Right now, as you watch this video, the sun could have already exploded, and you wouldn't know for 8 minutes and 20 seconds. That's how long it takes light to travel from the sun to Earth. 93 million miles at 186,000 miles per second. But here's what's terrifying. If the sun exploded right now, this very second, we'd have 8 minutes and 20 seconds of normal life before everything ends. 8 minutes to say goodbye. 8 minutes before Earth becomes a frozen, lifeless rock hurtling through space. 8 minutes before 8 billion people cease to exist. This isn't science fiction. This is physics. And in this video, we're going to walk through every single second of those final 8 minutes. What you'd see, what you'd feel, and what would happen to our planet. We'll explore the actual physics of stellar death, why the sun can't just explode like a bomb, what would cause it to die catastrophically, and whether humanity could possibly survive. We're covering the physics of how stars die, the 8-minute light delay that dooms us, second-by-second breakdown of Earth's final moments, and the one theoretical way humans might survive. This is going to be intense. If you want more deep-dive science documentaries like this, subscribe now. Let's begin the countdown. First, let's address the elephant in the room. The sun can't actually explode like a supernova. Our sun is too small. Stars that go supernova need to be at least 8 times more massive than our sun. Our sun is a G-type main sequence star, a yellow dwarf. It's actually pretty average. In about 5 billion years, the sun will naturally die by expanding into a red giant, swallowing Mercury, Venus, and possibly Earth, then collapsing into a white dwarf. But for this video, we're re-exploring a hypothetical catastrophic scenario. What if something caused the sun to release all its energy instantaneously? What if a quantum fluctuation, a collision with a massive dark matter object, or some unknown physics caused sudden stellar death? The sun outputs 3.8 times 10 superscript 2 watts every second. That's 386 billion megawatts. In 1 second, the sun produces more energy than humanity has used in our entire existence. If all that energy, the energy the sun will produce over billions of years, released in 1 instant, it would create a gamma ray burst powerful enough to sterilize everything within 50 light years. But here's the critical physics. Nothing travels faster than light. Not energy, not information, not gravitational waves. Einstein's special relativity is absolute. Light from the sun takes 8 minutes and 20 seconds to reach Earth. That means if the sun exploded right now, the light carrying that information and the deadly radiation wouldn't arrive for 8 minutes and 20 seconds. So let's walk through those final 8 minutes. Second by second, what would humanity experience in our last moments? For the first minute after the sun explodes, life on Earth continues exactly as normal. You're watching this video. People are driving to work. Kids are in school. The sun looks perfectly fine in the sky. 2 minutes in, still nothing. Scientists at solar observatories see normal solar activity. NASA's Solar Dynamics Observatory shows standard coronal loops. No alarms. No warnings. Around minute 3, something strange might happen. Neutrinos from the explosion would reach Earth first. They travel at nearly light speed and pass through matter easily. Neutrino detectors in Antarctica and Japan would suddenly register a massive spike, trillions of neutrinos flooding through Earth. Scientists would have maybe 5 minutes to realize what's happening. By minute 5, astronomers worldwide are in emergency meetings. Neutrino data suggests catastrophic solar event, but there's no protocol for this. No evacuation plan. No way to save 8 billion people in 3 minutes. Minute 7. Governments issue emergency broadcasts. Seek shelter immediately. But shelter won't help. Nothing will help. People flood into streets, staring at the sun, waiting. Minute 8. 30 seconds left. The sun still looks normal. Birds are chirping. The sky is blue. Then, 20 seconds. 10 seconds. 5, 4, 3, 2, 1. At exactly 8 minutes and 20 seconds, the light arrives. The sun suddenly becomes a billion times brighter, brighter than 1,000 suns. The sky turns white. Then, everything facing the sun vaporizes instantly. The atmosphere on the day side ignites. Oceans boil. Cities evaporate. Within 2 seconds, the entire day side of Earth is sterilized. Within 10 seconds, the shock wave of superheated atmosphere circles the planet, incinerating the night side. The gamma ray burst strips away Earth's atmosphere in seconds. Nitrogen and oxygen molecules are ripped apart by high-energy photons. Our protective blanket, gone. Without an atmosphere, there's no air pressure. Any remaining water boils instantly in the vacuum. Oceans evaporate into space. Mountains crumble from thermal shock. Here's something most people don't realize. Earth would continue orbiting. Even though the sun is gone, Earth's momentum keeps it moving in its orbital path. Actually, that's not quite right. Remember, gravity also travels at light speed. For 8 minutes and 20 seconds after the sun explodes, Earth still feels its gravitational pull. At minute timestamp 8:20/timestamp, when the light arrives, so does the gravitational information. Earth suddenly stops feeling the sun's gravity. We'd fly off in a straight line, tangent to our former orbit, at 67,000 miles per hour. Within hours, Earth's surface temperature drops to minus 100 degrees Fahrenheit. Within days, minus 200 degrees Fahrenheit. Within weeks, we'd reach minus 400 degrees Fahrenheit, close to absolute zero. Earth becomes a frozen ball of ice hurtling through the void. After a year, Earth's core would still be hot. Radioactive decay keeps it molten. But the surface would be a frozen wasteland, darker than the darkest night, silent, lifeless. Is there any possible way humanity could survive? Let's be brutally honest. 99.9999% of humans would die in the first hour. But there's one theoretical survival scenario: deep-sea submarines. Nuclear submarines can stay submerged for months, have their own oxygen generation, and are shielded from radiation. A submarine crew could survive the initial blast. But then what? No sunlight means no photosynthesis, no plants, no food chain.